Hello, my dear friends. How you all are doing today? I welcome you all to my YouTube channel, Cloud with Mohsin. So, friends, today's topic of discussion is Amazon Simple Queue service, which is in short called as SQS. So, it is a messaging service that is offered by AWS, and we are going to have a deep dive into all these features, its types, the use cases, and related things. So, let's get started with the discussion. First of all, let me quickly cover the contents that we'll be talking about. And see, today's session will be a theoretical session only, and we will have a hands-on lab in the next session. Okay. So, what I'm going to cover today is, as part of this discussion is, I will quickly discuss about what is an SQS, Amazon SQS service, how it works. Then we will touch base upon the common use cases of SQS, its types. Basically, it has two types, standard queue and FIFO queue, and we are going to see what are the differences between these two types. Then we will also cover about some of this concept, visibility, timeout, dead letter queue, and time to leave. And again, we will also have some more polling services like short polling, long polling, as well as we also touch base on the what is delay queue. Finally, we will just wrap up this session with the summary. Okay, I hope the agenda is clear. Okay, now, so let's get started with a discussion about what is an introduction to Amazon SQS. Okay, so SQS, that is also called a simple queue service. It is a fully managed service that provides message queuing functionality. Okay, so whenever you see SQS in the exam, the first thing you should notice, it is a message queuing service, and it is very important with respect to application integration that we are going to talk in how it works session. Okay, in that section we will talk about how it works. So it is a message queuing service that enables asynchronous communication between software components. So suppose you have different components in your application and you want to pass on some of the messages between the components. In that, instead of directly integrating those components with each other, we can use SQS in the middle of those as kind of a decoupling, it's called as. And it's very useful in that term. It allows application to exchange messages reliably and scalably. It is fully scalable, so you don't need to do anything. And as it is a fully managed service, so we should not worry about underlying infrastructure, it's scaling everything. It's very smart service. It will handle everything by its own. So please note, see, SQS is a pull-based service, which means messages are pulled by consumer. Okay. So in the upcoming sessions, I will also cover another session that is called as SNS, Simple Notification Service, which will be kind of, it will, SNS will push the messages, but SQS will be pulled. So there is a message producer and message consumer, and SQS, the consumer will pull the messages. Okay. It simplifies communication between different parts of your application and making it easier to build scalable and reliable systems. So as of now, you can think of SQS as a queuing service, message queues. So messages are passed. If there is a queue, logical queue, you can say, and it will be responsible to pass the messages between different components in your application. So there are mainly two types of the simple queue service. You can say not a type, maybe you can say configuration. One is called as standard queue, another is FIFO, that is first in first out queue. So these are basically with respect to how the messages are ordered. So we are going to cover it in the detail in the next few slides. Okay. Now I will talk about how SQS works. Okay. So here in this diagram you can see there's a message producer, which you can say an EC2 instance, and a message consumer, that is database. So for a moment, just consider, see, the message queue is not available or it's not existing. Okay, so in a normal scenario, when you have an application wherein you are directly passing your messages from your EC2 instance to your database. In that case, what could be the issue is, suppose your EC2 instance is generating messages, suppose in large number of extent, and your database is not able to handle those messages. So there could be bottleneck and at your database end, so it will be, overall your processing will be slower. So when using SQS, so this is called as, when we introduce SQS in between these components, this is called a decoupling service. Okay, so here EC2 instance, instead of passing it directly to database, the messages will be pushed to your queue, and from there the consumer will pull. So consumer will have to pull the messages from the queue. Okay, so that is in a very simple way SQS work. So the messages are stored redundantly across servers for high durability. It supports standard queue for high throughput and FIFO or strict auditing that will discuss in the upcoming session. And see, the messages will be available in this queue for a term or a time period, that is term as time to live, that is in short called as TTL. Okay, so it will be by default, the message will be available in the queue for 4 days, and it will get automatically deleted if you have not done any processing of those messages. It will get automatically deleted after TTL as 4 days. However, we can also configure this TTL so from 1 minute to 14 days. So if you wish, you can keep your message for 1 minute, or you can keep it for maximum time period of 14 days. So TTL can be from 1 minute to 14 days, but the default value of TTL is 4 days. I hope this makes sense. Okay, and the TTL allows you to set expiration time for messages in the queue. After the specified TTL, SQL automatically removes the expired messages. Okay, so if you have kept your TTL as 14 days, so all messages will be in queue for 14 days. Okay, but if you want to delete, to get those messages automatically deleted, what you can simply do is, once the messages are processed by your database, you will simply want it expire automatically instead of you going deleting that. Okay, so what you will do is, you can set the TTL value as per your requirement, and it gets automatically deleted. So that is the significance of TTL is. Now let's cover about some common use cases of SQS. So wherein all the SQS is being used. Okay. The first and very important use case of SQS is decoupling system. As we covered in the previous slide, the Amazon SQS allows to integrate and decouple distributed software systems and components. It helps keep individual microservices and distributed systems separate from each other. Okay, so mainly in microservices and distributed system, it plays kind of, it integrates with different components, and it will be decoupling your application in terms of, passing the messages from one end to another end. So that is, decoupling is very important use case. Message queuing. So Amazon SQS can be used to exchange and store messages between different parts of application. As we also covered in the last previous slide, producer sends messages to the queue and consumer retrieve them from the queue. This service ensures reliable message delivery and high availability. So the message, delivery, it also works as a message queuing system. Okay, and in that, it ensures the reliable message delivery and high availability. So messages will be highly available in your queue. Okay. Security and durability is also one of the major use case. So it's not like, we can also have a control of, who can access or read or receive the messages, and it is also, we can do ensure server side encryption is there. So in this way we can control, it's like we can configure who can access, who can receive the messages at the destination end. Like, we have full control on this part, that is message consumer, like who will be able to read these messages, so that it gives us better control in that terms with respect to security and durability. And lastly, it has one more use case about scalability and reliability. So SQL, it scales transparently to handle varying loads. Say suppose your load is varying. Okay, so in that way SQL will automatically scale itself. You don't need to do anything with respect to scaling. And the messages once are, inside your queue, it locks for, the time to live value. Okay, and in that time to live value, the consumer will process those messages. So there are some other concept as well, like visibility timeout. We are also going to see in the upcoming slide. So visibility timeout is simply, suppose you have this messages has produced some of the messages and are in the queue, and this your consumer. So there is a, no limitation that it should be one to one or something, like we can have multiple consumer at here. So in order for, say, suppose you have a message, say for example abcd, for example this is a message, and if you want that message should not be done or processed by multiple uh, destination entities or multiple consumer, what you can do is you can set up simply a visibility timeout. So the visibility timeout is the thing. What it will do is, once the message is in the queue, it so message will be disappeared until this it is processed by your consumer. So what is the benefit of that is, suppose you have 10 consumer here and you have suppose 5 messages. So you don't want all those consumer will be processing each of those messages. Okay, you should, because that is not also cost effective solution. You would want consumer will work smartly and process only that message. Okay, and the other consumer should focus on other messages. In that way you can use the visibility timeout. Okay, so these are some of the use cases of Amazon SQS. Now I will quickly cover about what are the types of SQS queues. So by now we are aware that there are two main types of SQS queue. So first is called a standard queue and other is called as FIFO, that is first in first out queue. And here are some of the differences in terms of message throughput, delivery and message orders. Okay, so these are the key differences. Based on this, the both the queues are has some variable or some has differences. So with respect to message throughput, so if we talk about standard queue, so the standard queue supports nearly unlimited number of API calls per second per action. So in short you can say, there is no limitation of number of messages or action that standard queue is able to process, or it can be stored in that. So the API action like send message, receive message or delete message, see these are some of the actions, and standard queue is it do not have any restriction in terms of how many such activities it can perform. It's nearly unlimited, you can say. However, FIFO has some limitation. So it can support only up to 300 API calls per second. So this is when you have not batched, okay? And it's up to 3000 messages. So when you suppose you're doing in a batch, like you are keeping the messages in a batch of say 10 messages in one batch, in that way it can process up to 3000, so 10 messages per batch. So FIFO queue has some limitation in terms of how much throughput you can deliver. So that is first difference. So with respect to delivery, so with standard queue, it's at least one delivery. So messages are delivered at least once, but occasionally more than one copy may be delivered. So here with standard queue, what can happen is you can receive your message. There could be some duplicate messages can be delivered as well. So if your application don't want that, application just want a message should be received only at once, then standard queue won't be suitable in that case. However, in case of FIFO, that is first in first out, it is exactly once processing. So messages are delivered once and remain available until consumer processes and deletes them, and there are no duplicates are introduced. So with respect to FIFO, it will be like first in and first out, and it will process a message exactly only once. There are no duplicates with respect to FIFO queue. Now message orders. So with respect to standard queue, so message orders, as it's not, there is no such order. So it's not like you have one first message received. So with standard queue, it will be delivered uh, in a sequence. It's not like so. It is occasionally, it's occasional, and messages are delivered out of order. So the order could be, suppose there are 5 messages, 1 2 3 4 5. So first can be delivered, then after first it's not necessarily second, it will be third or fifth or fourth. Okay, so there is no order in which messages are delivered at the destination end for consumer to process. But FIFO has distinctly very different in that term. It is first in first out. It's the name itself suggests first in first out delivery. So it also orders the strict strict delivery messages. So in which the strictly preserve the order in which messages are sent and received. So you, if you have five messages, it will be delivered in the sequence only. So that is about FIFO queue. So with respect to exam as well, this is very important. You need to understand. Mainly, you should focus about throughput. So when suppose a question mentions about unlimited throughput, so you should think about standard queue only. And if the message or in a question, if it refers to say exactly once delivery or no duplicates, then you need to go for FIFO only in that case. Okay, so that is very important for you to understand. Now I will touch base about few other concepts with respect to SQS, and these are also very important with respect to exam. If you are preparing for say practitioner or solution architect associate, so this is very important. So first of all, visibility timeout. As we have covered earlier, so visibility timeout is a time for which suppose a messages is, or it is a message is something called as locked by a consumer. So when a consumer receives a message from a queue, it remains in the queue until explicitly deleted. To prevent other consumers from processing the same message, SQS sets a visibility timeout. Okay. During this period, other consumers cannot receive or process this message. So because of that, SQS is very important because it will ensure same message is not processed by multiple consumer. So to avoid that, we can set up visibility timeout. So the timeout, as it suggests, it is related to time frame. The default visibility timeout is 30 seconds, but it can be adjusted for minimum 0 seconds and maximum up to 12 hours. Okay. So what will happen, suppose if you have set a visibility timeout for 12 hours is, let me go back to this diagram again. Suppose if you have set your visibility timeout for 12 hours, okay, if a message is in the queue, and suppose this database is which is a message consumer is processing that, and let's consider we have another database as well. So the other database cannot able to process that message, okay, until 12 hours are passed, until that is processed by this message consumer. Okay, so that is with respect to your visibility timeout. Time to live we have already covered. It is the expiration time for which message will be in the queue. So it is default is 4 hours, maximum is 14 days, and minimum is 1 minute. So we can set it is basically how long the message will be there in the queue until it gets automatically expired. Okay, so you need to choose this value very carefully. Suppose if your application requires your message should not get deleted before suppose 6 hours or 10 hours, so you should set it accordingly. Otherwise what could happen is, before your application processing that message, if the value is very low, then the message will get already automatically expired and won't be able to be processed by your consumer. Okay, so you need to choose this value very carefully. A dead letter queue. So you can suppose you might think, if the consumer is processing a message in the queue and it's not able to process that, or it's failed to process, what could happen to those messages? Will those messages will be processed again or get automatically deleted? What? So to avoid these kind of use cases, AWS has introduced this concept called as dead letter queue. So in that DLQ, which is in short called as DLQ, it serves as a target for messages that fail processing. So all those messages which are failed with respect to processing are available in the dead letter queue. When a message repeatedly fails, example given due to errors, it's moved to DLQ, and it helps to isolate problematic messages for debugging and analysis as well. So if you have suppose a particular message keeps failing due to some error, you can debug and analyze with respect to DLQ, and we can troubleshoot accordingly. So see, DLQ is not a separate queue type. So when we'll have a hands-on lab, I will show you. It is derived from your, it can be either standard queue or FIFO queue. We can either choose, and you can configure it as a DLQ, dead letter queue, so that you can it will store or keep your messages which are failed for processing. Okay. Now, similar to DLQ, that is dead letter queue, we also have something called as delay queue. As the name suggests, a delay queue, it introduces a delay before messages become visible to consumers. And it is useful for the scenarios where we want to postpone a message processing. For example, we can set a 5-minute delay before critical notifications are processed. So exactly, so delay queue is something. See, if you want your message should get delayed by suppose particular time, in that case you can configure delay queue, and it is especially useful suppose if you want to postpone intentionally your messages before consumer processes that. Okay, in that case, delay queue is very important. Now, with respect to polling, the Amazon SQS offers two polling options for receiving message from a queue, that is short polling and long polling. Okay, so these are again not the different type, but different configurations, and I will show you what is the reason for that one. We have short polling and we have long polling. Better I will go back to my this image. Okay, say if you want your you want your consumer should check, because this is a pulled based service, that your consumer will always go back to your SQS queue to check if there are new messages for the processing. Okay, that is it called as pulled based service. So if you want your consumer to go back frequently, okay, or in a short time to check the queue whether there are messages, then you can go for short polling. In It's as simple as that. So, and if you want your consumer to, should not check occasionally or to check after a long time, then you can go for SQS long polling. You can configure that. So we will ask me, okay, what is the benefit of using both, or how that can be done. So with respect to that, there's a parameter that we need to set up here. So there is parameter that is called as the receive message API action. Okay, so if we set this receive message value as 0, then it will be by default short polling. In that, what will happen is it is suitable when immediate message processing is required. So suppose you want your messages to be processed once, as soon as it is in the queue and you want it to be processed, you can go for short polling. And when you set the value as 0, then it will be short polling for receive message action. But if you set the value for, it's the value is from, I believe it's 0, it will be short polling. And if you set value non-zero, so it is from 1 second to 20 seconds, so you can go for the long polling. So long polling will be benefit if you suppose, uh, if you want your consumer to sit idle and should not check, even the message, there is no queue, no message in the queue, and to reduce the cost. Because what will happen is, if there are no message and still you have configured short polling, it will check again and again, and there will be some compute resources that will be used. So if you don't want that and you want a suppose cost effective solution, then you can go for long polling, because it reduces number of empty responses and hence lowers the cost related to message wait time. Okay, so this is very important. Again, this point is important with respect to exam. If you are looking for say cost effective solution with respect to polling, then long polling will be always preferred, because it will check only as and when the message will be available based on the receive message API action. Whereas short polling is something, it goes immediately check, even there are no messages in the queue, it keeps checking for that time. So these are the differences. Now we are at the end of this session today. I will just quickly summarize what we covered today. So we talked about what is SQS. So SQS, that is Amazon Simple Queue Service, is a fully managed messaging service. It is offered by AWS and it enables asynchronous communication between software components. Okay, it allows application to exchange messages reliably and scalably. It producers, so we have seen the diagram. The producer will send a message to the queue and consumers retrieves them. The default retention time, that is also we referred as time to live, it is for the time period the queue will be, or messages will be available in the queue. So by default it is 4 day, and before it's being automatically deleted, but we can configure this TTL between 1 minute as minimum and 14 days as maximum. It supports both types of queue: standard queue, which is recommended for high throughput because it processes unlimited throughput, and FIFO queue if you need exactly once processing, and in the strict order you can go for FIFO, that is first in first out queue. We also touch base about visibility, timed out, dead letter queue, delay queue, time to live, and some other features of SQS. So visibility timeout is something that you want other consumers should not process your, the message. You can set the visibility timeout. It will be locked. You can say a message will be locked for processing by one consumer at a time. Okay. In that case, you can set the visibility timer. Dead letter queue is something the messages which are failed to be processed will be picked up by DLQ. It is derived from either standard queue or FIFO queue. Okay. Delay queue is something when you want your messages to be postponed intentionally, you can make use of delay queue. Time to live I already covered. It is same. It is the retention period for which your SQ message will be available in the queue. Then we also covered about two polling options for receiving messages from a queue. So those two options are short polling and long polling. So you can go for short polling when the immediate message processing is required, or when polling multiple queues in a single thread. So in that case, you can go for short polling. And when the wait time, so in case of short polling, the receive message API action will be zero. That parameter view, it will be zero, then it will be short polling. But if you set this receive message API action a non-zero value, like you can set from 1 second to 20 seconds, then it will be long polling. So it reduces number of empty responses and hence lowers the cost related to message wait time. So it will be reducing your cost related to that, and long polling is more cost effective than short polling. Then finally, we also covered about some of the use cases of SQS, which are decoupling systems. So simply, decoupling means you have works as application integration. You can place it between the software components. It works as a message queue. It got security and reliability that you can control who can access, read, or receive your messages from the queue. It is also scalable because it's being fully managed service, so it can be scaled automatically. You don't need to worry about that, and it's also reliable because we also have uh, the messages will be available. It ensures high availability there, so it will ensure that one. And along with that, we can also configure server side encryption as well. So these are some of the things I wanted to discuss in today's topic. And in the next slide, next session, I will try to cover a hands-on lab. We will see how a message can be processed using SQSQ, either standard or FIFO. That we will make use of that. So, friends, that's it for today. I hope this session was useful for you to understand how a messages queue service is offered by AWS work and its features. And I believe this will give some heads up for you to prepare with respect to your exams. So thank you friends for your time. Please don't forget to like, share, comment, and subscribe to my YouTube channel. This is Cloud with Mohsin. And if you have any questions with respect to this session, just make use of your comment section. And unfortunately, we don't have SQS for me to for to receive messages at this point of time. So just you can understand that. So thank you so much, and have a great day ahead. Take care. Bye bye.